My name is Madison Dierks, and I'm a fourth-year landscape architecture student at Iowa State University. And this is my final project for LA 478K, Parametric Design and Landscape Computing. And for my final project, I wanted to create a program that would show the shadows of a structure on a specific day at specific increments of time. And I feel that this is really important to landscape architecture as a profession because so much of what we design is based on the sun, whether it be planting plan or even site-specific design with where we place our benches or shading structures. So for this program, I calculated the length of shadows for a 10-foot tall building on December 21st, 2014 in Ames, Iowa. So the first thing I did for this was create a program that created 4 suns, because I knew I wanted to have interactivity and eventually I wanted to make suns become buttons, and I wanted there to be a relationship between where the suns on the screen were and the shadows that were created. So to do this, I created functions, and I just created 4 separate functions that each had a set of parameters and that involved where the center of the ellipse was placed. The second thing I did was create shadows, and so I had already calculated the shadow length using a specific equation, and I then created a new type of function that would create the outlines for shadows. And so to do this, I just created lines from the center points of what I'm calling my building, which is this black rectangle here. And I also manipulated my sun program to be a loop at the beginning. And so from there, I decided that I wanted to make my suns coincide directly with the direction of the shadows. So I could point to this and be like, the shadow from this sun is this one, and it was visually more appealing. And so from there, I decided to just make the shadows even more realistic by adding that third line, which represents the way the shadow would actually look from the building. But because this was still a little bit lacking in communication from which sun corresponded with which direct shadow, I took it to the next step and I decided to kind of color code the shadows to the suns. So there's a direct relationship between the color and the shadow that it's supposed to reflect. But after doing that, I realized that things weren't quite right with the shadows because they weren't directly reflecting how a shadow would actually look throughout the day. So on the shortest day of the year in 2014, you would have the sun at 8 a.m., 9 a.m., 10 a.m., 11 a.m., noon, 1 p.m., 2 p.m., 3 p.m., 4 p.m., and there wasn't a direct translation. So I wanted to create a code that did that. And so for my next step, I changed the angle at which the shadows were placed. And so to do this, originally I had been using just the same angle for everything. So I used a more realistic angle with what the angle of the sun changes on each hour on that specific day. And so starting at the 90 degrees, I slowly went down, so you can kind of see that direct translation. And because of where Ames, Iowa falls in the northern hemisphere, their noon shadow, there is actually a shadow cast. So I was able to get more realistic with this, but I felt that I really wanted there to be more interactivity, and I wanted you to be able to see directly at 8 a.m. which shadow was being cast, because there was still some ambiguity there. And so I created a code using if and else statements that caused my shadows to be drawn when I drag my mouse over each sun. And so to do this, I used if and else statements, and I had to calculate the center of each of these ellipses, And so to do that, I did some hard coding, which I used this equation to solve for both my CSX and my CSYs for all of them. And those are those equations there that then get plugged into my if or else statements. And so from there, I decided that I wanted my shadows to actually disappear if there was no mouse over top of it. I wanted to be extremely clear what the shadow looked like for each time of day. So to do that, I added one line of code, which actually ends up being in draw. If you just draw the background, it does this for you. And each time you move the mouse to a new sun, just the shadow that you are, the shadow for the sun that you are hovering over is shown. And so in the future, I would like to make this program less hard-coded and make it so you could type in the sun angle and have all of these change for you without having to do the math manually. And I would also include the calculator for the shadow length, so there was more, so you were able to type in the height of the building and your longitude and latitude to figure out what the sun would be on that day. So there'd be a lot less of hand or paper calculations and have the program do more of that for you. Thank you.